Hello, Jim. Good evening. We'll start after 2 minutes.
Hello, good evening, sir. Happy Teachers Day.
Happy Teachers' Day. Good evening, Charun. I think we can start now. So I believe I am loud and clear and my screen is visible. So we can start. So happy Teachers Day, everyone. I am Sutanu Sadhu Khan, PhD student of IIT Bombay. I am your facilitator of the weekly interactive session. Welcome to the week 5 of NPTEL course code C86, that is Water Economics and Governance, offered by NPTEL, and course instructor is Dr. Manoj Kumar Tiwari of IIT Kharagpur. So we are the sixth session. So after this, 50% of the sessions will be covered today, and the first 5 sessions we have already covered in the month of August. If you have got any query or any feedback regarding all the sessions that those are conducted in August, then you can speak up or you can type in the chat box. So last week, actually, we studied different things regarding the pricing methodologies which are based on the water consumption. So today, actually, last week also we also told that certain graphical representations are left. So after solving these MCQs, the theories those we studied either in the last class or those were taught by sir in week 6 lectures last week. So those will be more clearer after solving these MCQs. Okay. So there will be 4 or 5 MCQs based on the graphical representation of the monthly water bill. Those are calculated or represented uh, depending on the monthly water consumptions in kiloliter. Here you can see there are 4 graphs. So the green line represents the model C. The blue line, this one represents the model A. The red line or brown line represents the model B, and model D is represented by the yellow line. So I think it is clear. So few MCQs we will see based on the graphical representation of the water billing methodology. So the first MCQ for you is which one of the following is or are consumption based models? So option A is all the models A, B, C, and D. Option B is models B, C, and D. Option C is model B and D, that is the red line and the yellow line. And option D is models A, B, and D. You can type your answer in the chat box. I'll wait for 2 minutes. Okay. Option all the 4 models Ojim is telling us the consumption based models. Okay. So I mean the last 5 sessions, if any of one of you have any concern or feedback, you can give meanwhile. And Choran, any response from you? You can type in the chat box your answer for this MCQ or any uh, concern regarding previous session. Okay, so we'll go with the answer. So the answer is option A, B, and D. Why C is not a consumption-based model? We'll see which one is C. C is the green line. That is this one. Here we can see the water bill, which is represented in rupees. That is rupees 100 in case of model C, which is constant uh, throughout with respect to the monthly water consumption. So monthly water consumption is varying from 0 to 50, but the pricing is not varying here. So it is remaining constant. So we can say that the monthly water consumption has no influence over the billing in case of model C. So that's why the C option, actually this model C is not a consumption based model. The other models A, B, and D, in all the cases we can see that we as the monthly water consumption is increasing, the uh, pricing is also varying. So there are certain influence of the water consumption on the pricing. What is the influence? That is not the question. Some are linear influence, in the in this case, that is model A, blue line, we can see the relationship is non-linear, but it has got certain influence. So these are all consumption based, whereas the C is not. Okay, so we'll move on to the next MCQ. That is model A, that is the blue line. This one represents a increased block tariff structure, two-part tariff structure, uniform tariff structure, and flat rate model. So we actually calculated a problem in the last class based on the model A. In this class also we will solve certain problem. Those who didn't attend the last class, they will be able to understand. Anyways, the recording will also be available. You can always go back and look into that. So here you can type your answer in the chat box, and there are four options. Among the four options, one option is there. We solve we solved a problem on that. During solving the problem, we mentioned that later this concept will be much more clear when we will be solving the MCQs. Okay, Jobin or any other. My slides are visible to you, right? You can type your answer based on the graphical representation of the pricing structure. So from the previous question, we can see that model A is definitely a uh, consumption dependent model, because in case of model A, as the consumption is varying, the pricing is also varying. But so basically the flat rate model rules out here. The two-part tariff structure we can also eliminate, as we can see there are one, two, three, four parts are there, four or five, I think. So there are more than two parts. So this tariff structure also gets ruled out as per the definition we saw in the last structure. Now, so are you able to answer anyone? Okay, so I'll answer this. So basically, it is a your increased blocks tariff structure, as we saw in the last class. So this kind of tariff structure is suitable for pricing rich families or pricing luxurious use of water, but this kind of tariff structure are not suitable for pricing poor but large families, where metering is done only per family basis and not per capita basis. So why this increased block study? Because we can see that the pricing is increasing as we increase the monthly water consumption. So the rate, so this is a different rate, this is a different rate, this is a different rate. So there are four parts. So four parts are represented by different linear relationships with respect to the monthly water consumption. But the model B and model D, the yellow line and the red line, these are basically uniform. So the rate is represented only by a single linear relationship with respect to the monthly water consumption. But the A is a increased block study structure. Okay. So we'll move on to the next MCQ. The model which charges consumers even for zero consumption or no consumption. So whenever monthly consumption in kiloliter is zero, even for a minimum service requirement, this kind of model actually charges the consumer. So option A is only model C, that is the green line. Option B is only model B, that is the red line. Option C is model B and C, that is the brown and the green line, and model A, B, and C. This is the option 4. So please type your answer in the chat box. Jobin is saying option C, model B and C. Okay, I believe the colors are clearly visible to you, right? If this is not, then I can just indicate it on the screen. Okay, so I believe it is correct. You are telling option C, that is B and C, right? So B means the brown line and C means the green line. Yes, 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 it is true. So option C is the correct answer, because whenever the monthly water consumption is zero, you can see a positive value. In case of model C, it is 100, and in case of model B, it is 200 or slightly less than 200 or so. So actually, even if the consumption is zero, just for having the connection. For example, some of you are having cable line connection, or some of you are having uh, internet connection in your home. That is your basically LAN connection. So you can see that there is a fixed charge sometimes, even if your usage is zero, just for providing the service. So similarly, in case of water also, so just for the service, there might be a minimum charge in some models. In some models, it may be zero also. In your mobile also, you see sometimes that if the charge is you are being charged, even if you are not utilizing your data balance or your SMS balance, it is just getting wasted. So this kind of models has that kind of drawback. The question can be modified a bit, that in which cases it may be asked that the minimum consumption or zero consumption incurs a certain amount of charge, as well as the uh, rate is uniform throughout the consumption, then only model B would be the answer, because we can see that in case of model C, it is a flat rate, and throughout the consumption rate, the monthly water bill is not uniform, or linear or any kind of relationship. It is not there. It is completely independent of that. But as that is not been mentioned in the question, only the charges for non-zero consumption is being mentioned. So that's why option C is the correct. Okay. So we'll move on to the next MCQ. Okay, MCQs are over. So now we'll solve a problem which is based on the increasing block study structure. That was model A in our case, because we can see there are 4 blocks, and within which the tariffs are if you just fall in certain range of consumption. For example, if you fall in between 20 and 30, there is certain relationship. If you fall between 10 and 20, there is certain relationship. And as you increase the amount of usage, the more will be the monthly water bill. So this problem is actually based on that. So the problem is as follows. You are advised to keep your copies and pens with you, so that you can note down the important information and solve the problem by yourself. Don't be shy away of solving the problems, because this is just a practice session, just for increasing your knowledge. It will not be evaluated. Okay. So the problem is as follows. Water charges for residential consumers in Nagpur city is fixed as rupees 8.55 per kiloliter for up to 20 kiloliter, rupees 13.68 per kiloliter for consumption between 21 and 30 kiloliter, rupees 18.82 per kiloliter for consumption between 31 and 80 kiloliters, and rupees 25.66 per kiloliter for consumption beyond 80 kiloliter. So for a household from Nagpur, answer the following sub questions. Number one is, if the monthly water consumption is 40 kiloliter, then what will be the monthly water bill in rupees? We solved a similar problem in the last class. Option 2, second question is asking, if the household wants to pay maximum of rupees 600 per month for their water bill, the monthly consumption should be limited to in kiloliters. Now, question 3 is asking, if an alternate water service provider is supplying water at a uniform rate of rupees 15 per kiloliter, that is, he or she is following the model D. So there is no minimum service charge. If the minimum service charge is mentioned, then it would follow model B. But as it is not mentioned in our case, in the third question, it is just mentioned as 15 kiloliter, 15 rupees 15 per kiloliter. So beyond which level of monthly consumption, it is beneficial to switch to the alternative water service providers. So the monthly consumption value in kiloliters you will have to calculate. So the number one question that is asking uh, just the monthly water consumption. If it is 40 kiloliter, what will be the water bill? This is a just straightforward problem as we solved in the last class. So I think it should not take much time for you to answer the first question. So I'll wait for some time for you to solve the question, and I'll clarify one thing here, that it is saying that below 80 kiloliter it is 25.66, uh, and from 31 to 80 kiloliter it is 18.82. That 31 basically means below, beyond 30. So the consumption which is falling in between 30 and 31, for example 30.5 or 30.6 something, that will be considered as 31. If it is 30 only just 30, then only it will fall between these two, this range 21 to 30. And also similarly, if the consumption is up to 20 kiloliter, then it is 8.55 rupees per kiloliter. If it is beyond 20, that is 20.5 or 20.6 or 20.3 something, then it will fall within this block, that is in between 21 and 30. So which is 13.68 per kiloliter. So if the water consumption is 40 kiloliter, which falls within this category, that is 31 and 80 kiloliter, then what will be the monthly water bill? So as we saw in the last class, you should not directly multiply this 40 kiloliter with 18.82. You should not do this. You have to blockwise calculate, and the amount of 40 kiloliter that is just uh, within this block, only that amount you should multiply with 18.82. Okay, anybody? Okay, Ajim has calculated. I think it is correct answer. Okay, we'll go with the solution then. So the digital solution, the data given, the range is given as I told. So beyond 80, and it is beyond 30. The third block is beyond 30, and the second block is beyond 20. So 20 was in one is included, and 20 is included in the first blocks. Beyond 20, everything is within this block, and also similarly in the other blocks, higher blocks also. So the water bill for 40 kiloliter consumption will be within the 40, the first 20 falls in the first block, the second 10 falls in the second block, and the amount that is left from 40 minus 20 minus 10, that is again 10, that falls into the third category. So it is 22 rupees 8.55 plus 10 into rupees 13.68 plus 10 into rupees 18.82, which equals to 171 plus 137 plus 188, that is 496, as you have correctly calculated. So if your answer falls within this range, that is 475 and 515, then it is true. Now we'll solve the second question, which is a bit complicated. If the household wants to pay maximum of rupees 600 per month for their water bill, then what will be the monthly consumption? So what will within what consumption they should limit their monthly consumption? So do you want to try this one? Okay, Ajim has already calculated 45.52. I think again you are correct on, because it fall between the range of 45 and 50. I think. Okay, we'll see. So the real solution is as follows. So again, the monthly consumption slab and the individual rates are provided for your understanding and for your convenience. So now here you have to calculate the water consumption for monthly bill of 600. That is your maximum consumption you can do in order to keep your water bill 600 or below. So as we calculated in the earlier problem, water bill for 40 kiloliter consumption is rupees 496. Now from 600, the amount that is left as per our previous calculation, that is 600 minus 496, rupees 104. So if the above amount comes under the third slab, that is in between 30 and 80, then the respective quantity of water will be as follows. So rupees 104 divided by rupees 18.82 kiloliter, that is the rate of the third slab, which is nothing but 5.526 kiloliter. So we can see that quantity of water left from the third slab is 80 minus 40 kiloliter, is basically your 50 minus 10 kiloliter, that is 40 kiloliter. And the 5.526 kiloliter is within this limit. So it is not crossing your 40 kiloliter. Okay. So this 40, I think you are able to understand this. If any doubt, you can ask questions. So this 40 kiloliter consumption we calculated for our last problem. Now, the amount in the third slab that is left beyond that 40 kiloliter we calculated, that is your 40 kiloliter. Again, okay. So that's why the amount we calculated, that is 5.53 kiloliter, it is less than the 40 kiloliter. That's why it is acceptable. That means we can safely say that the rupees 600 will to limit the monthly consumption or monthly water bill within 600, you have to be in the third slab. If it was crossing the 40 kiloliter limit, then it would fall at the fourth slab. Then calculation would be done accordingly. So here, as it is in the third slab and it is 5.53 is 40 kiloliter, then third slab is 5.53 kiloliter is less than the 40 kiloliter, then the third slab is acceptable. I hope it is clear. So hence the acceptable range of answer will be 40 plus 5.526 kiloliter, which is 45.53 kiloliter. If your answer is between 43 and 48, then it is correct. Yes. So it is 43 and 48. Answer is correct. Now we'll solve the third problem, which is a bit more complicated. So if an alternative water service provider is supply water at a uniform rate of 15 rupees 15 per kiloliter. So here you can see the blocks are varying from 8 to 13, from 13 to 18, and from 18 to 25, depending on the consumption. But here, whatever your consumption is, the supplier is only charging rupees 15 per kiloliter. Now, you have to calculate beyond which level of monthly consumption it is beneficial to switch to the alternative service provider. So if your monthly consumption is such and such, let's say if it is uh, your let's say it is 50 kiloliter. So you can say that if your consumption is below 50 kiloliter, you can it is economically beneficial for you to go with the initial supplier. And if your let's say your calculated value is 50 kiloliter, and if your consumption is more than the 50 kiloliter, you can uh, say that the you have to it is beneficial for you to go with the second supplier. So you have to actually determine your family consumption, or you have to make a guess of your of the monthly water consumption of your household at the initial stage. That means at the starting of your journey with your new home, at the starting of residing your new house. Then only you have to decide, because in the meantime you cannot just switch between two supplier, or you can if suddenly your consumption monthly consumption is increasing, then you can uh, just replace your connection line from the old supplier to the new supplier if it is increasing, or if it is decreasing. So that limit you have to calculate basically. So at a single time, you cannot go with both the suppliers. If that was so, then the calculation would be different. You have to go either with this supplier or with the other supplier, either the block rate structure or the uniform rate structure. In that scenario, what will be your threshold water consumption rate per month in kiloliter that you have to calculate? Okay, you have anyone of you have calculated? Choron and Jobin, you also try. It is a bit complicated and it will take time. So I'll give 2 more minutes for you to solve. I mean, not complicated. Conceptually, it is very easy, but it is a bit calculative. So if you are wrong in any step, then the answer may be difficult for you to calculate. Otherwise, it is conceptually. If you are visualizing the block structure, what are the blocks, what are the value? If you are visualizing that where it may fall, most probably, then I think it is easy. A preliminary understanding is that uh, there are actually 4 blocks in the previous supplier, below 20 and below, uh, above 30. Sorry, there are, I think, one, two, three, four. Sorry, yes, 4 blocks are there, and above 30 and above 80. So you can see that in the first block, the rate is 8.55, in the second block is 13.68, and in third block it is 18.82. And the uniform in the uniform tariff model, it is 15 per kiloliter. So at the from the second to the third, actually it is switching. So Either in the a preliminary understanding is that the monthly consumption will be either in the second block or in the third block. It cannot fall in the first and the fourth block. So it is just a preliminary observation, but more precisely we will see. Okay, so doubt on that in understanding the question. So I think I can go with the solution, or you will try, or 1 or 2 more minutes I can give. Otherwise, I'll go the solution. It is a bit calculative, nothing else. You can assume any algebraic function. Okay, and then so I 48.8. Tell you, it is in the third block, right? I think it is correct. I do not know exact value because that value will fall in the third block. That as far as I remember. So therefore, I'll go with the solution. Uh, so these are basically the tariff rates, and in the alternative rate, it is provided that it is 15 in all of the blocks in rupees per kiloliter unit. So the conventional water bill for 30 kiloliter consumption, that is at the end of the second block, it is uh, 171, that is 8.55 into 15, that is 171. So sorry, I was wrong. That is 20 into 8.55, that is 171, plus 13.68 into this range, that is 10, that is 136.8 equals to 307.8. Now conventional water bill for 80 kiloliters consumption, that is at the end of third block. Why we are calculating at the end of second and third block? Because from our preliminary understanding, we have seen that the 15, this value is between the second block and the third block. So that's why we are calculating at these two ranges. So for the conventional water bill for the 80 kiloliter consumption is this rupees 307.8, that was at the end of the second block, plus 18.82 into 50, that is your basically 941 equals to rupees 1248.8. Now alternative water bill, that is the alternative service provider is providing for up to 30 kiloliter consumption is this 15 into 20, that is 300, plus this 15 into 10, that is 150 equals to 450. So your water consumption up to for first block and second block by the alternative service provider is rupees 450, which we can see that it is more than the conventional one. So alternative 30 is more than the conventional 30 in terms of water bill. Now alternative water bill at the end of the third block, that is 80 kiloliter consumption, is this rupees. Sorry, there is some problem, I think. Okay, so actually it will be 450. 450 plus rupees 750. So I think the calculation there is a bit 15 into it will be 50. So okay, this is correct. So it will be basically 450. That means it will be 1200 or something. But still, it will be less than the uh, 80 kiloliter water consumption. So I will correct it. Just wait. Just wait 2 minutes. So it will be your 450 and it will be 1200. I believe I am correct in this calculation. Okay. Uh, okay. So still, even if it is 400 or 450, you can see that for 80 kiloliter consumption, it is less than the conventional 80 kiloliter water bill. But previously, up to 30, it was more than. So the switching is happening in the third block only, because here you can see that the alternative is more than the conventional, and here you can see the alternative is less than the conventional. So the in between somewhere the switching is happening. So that's why we are assuming a algebraic quantity, that is x, which is in between the third block's limits, that is 30 and 80, is the level of monthly switch over consumption, and we can see it is present in the third slab. Now an equation, algebraic equation, you have to form. So how it is forming, I'll explain a bit. Most of you, I think, you have you have understood this, but still for the sake of others, we will explain it. Those who will be watching later this recording. So we can see that up to 30 kiloliter, the conventional water bill is 307.8 as we calculated, and the alternative water bill is 450. We have calculated it. So we are assuming a quantity X which is lying in between 30 and 80. So the X is the your ultimate consumption value. So the amount of consumption value from X that is lying only within the third slab, that is your X minus 30 in both cases. So in the conventional case or in the first case, the 18.82, this is your water charge. So it is multiplied with the amount that is falling in the third slab. And in the alternative case, x minus 30 is again the same quantity into, this is your rate. So 15 plus 15 into x minus 30. So this is your total bill in case of alternate service provider, and the left hand side is your bill that is charged by the conventional water supply, and x is the point at which the switchover is occurring. That means what? That at the point x, the water bill by the alternative provider is becoming less than the conventional provider. So beyond the point x, it is beneficial to go with the alternative service provider, and below the point x, it is beneficial to go with the uh, conventional provider. Sorry, below the yes, yes. So below x, it is beneficial to go with the conventional provider, and beyond x, it is beneficial to go the alternative rate provider. So if you just plot a graph, so we can go with the pen. So graph will be something like this. So there will be a crossover point. Sorry, I am bad in handwriting. It is difficult. I think pictorially you are able to understand it. What I am making you to understand. So actually, so if you there is a crossover point. So both are basically uniform service rates. So the conventional provider is actually uh, becoming more. at certain consumption value. So this is basically your rupees versus consumption graph. So at certain point, it is a threshold point which is lying between 30 and 80, these two values. So beyond this value, your alternate service provider charge is becoming less, total service, total water bill, than the conventional. I think it is clear. Okay, so now you just have to solve the equation. Just x minus 30 we brought in one side, 18.82 minus 15, it is 3.82, and 307.8, this gets subtracted with 450, it becomes 142.2. So x minus 30 becomes 37.225. This is the amount of water that is falling in the third slab only. So the acceptable range of answer, that will be your the value of water up to the third slab is up to the second slab, that is 30, plus the amount of excess that is falling in the third slab, so 37.225, which comes out to be 67.23 kiloliter. So I think uh, your understanding is clear up to here. So I think, Ojim, what you have calculated 48.8, it is, I think, if you are switching, if both the suppliers are available to you at the same time, but here the problem is a bit different. So you have to go to either with this supplier or that supplier. So there is no, I mean, both option is not available. So that's why the problem is. Otherwise, I think up to so that I discussed at the beginning of the point. So I think otherwise it is clear to you, right? Whatever we have discussed till now, because third problem is a bit complicated, not much. So how we arrived at this value 67.23, which is lying at the third range, and the total monthly water bill that is surplusing in case of conventional one than the alternative one, if you cross the consumption value, which is beyond 68 or something. So I think it is clear. The formation of the equations, and if you have any problem with that, you can just, any one of you are, if you're having any problem, you can just tell me. Otherwise, I'll continue. Okay. So we'll move on to the next MCQ, which is as follows. Tools to ensure financial viability of water utilities include option A, government subsidies, option B, voluntary contributions from customers to ensure water supply, option C is progressive tariffs aiming to recover cost from users, and option D, all of the above. You can type your answer in the chat box. Jobin, you're not answering. Go ahead. Don't be shy away. It's just a practice session. For attending, you can. It is appreciated that you actively participate. Or if you are having any feedback, if you want to say something that, say, I'm not understanding or something, you can always speak up. I think I mean, it is reasonable speed. It is not very fast. Even it may be boring for some of you. Maybe understanding, if you, those who are having, people who are having a PhD background. I mean, if you had mathematics in plus 2 level, then the entire course is, I don't think it is very difficult to you. If you didn't have, yeah, if some of you didn't have mathematics in the plus 2 level, then also most of the problems are pretty clear to you. But some of the problems, as we discussed in the last class, the kinetic equation of the BOD level. I am not sure the integration differentiation, those are in 10th level also now. But when I studied in my plus 2 level, then in the 10th level it was not there. So I studied differentiation, integration, those things in plus 2 level. Okay. Now many of you are in the MTech and PhD level also. So it is very easy subject, I think. But yes, for the sake of assignment solving and everything. So we are just practicing so that you don't have to again practice any questions from the books and so. So if you are just attending the whatever lectures I have sir given and whatever the practice session slides, you just go through them. Then only you will be able to easily answer the final questions. Those will be given in the either those are coming in the assignments or those will be given in your final exam. So those things will be very easy to you. Okay. So the explanation is government subsidies, voluntary contributions from consumers to ensure water supply, increasing but declining block study. Two-part studies are some of the tools to ensure financial viability of water utilities. So all of the above is true in this case to ensure financial viability of water utilities. Government subsidies is why it is viable, because it is required for to provide the water services for the people who are below poverty line level or who are unable to pay for the minimum value for water usages. Because it is so, so that's why government subsidy is important. But government cannot provide subsidy for everyone. So that's why the how the cost recovery will come into the picture. That means how the revenue will be generated, and those things also come into the picture. So basically for middle class of people, they may or may not, so the higher middle class people may be willing to pay for the water usage, and lower middle class people may not be willing to pay for the usage of water. But the rich people should pay for the water for their luxurious uses and everything. So that means those are essential, because subsidy, it is not desired that their water usage will be subsidized for but or water usage will be subsidized for their luxurious usage of water. So that's why all the three are important for all, depending on the all economic classes of people, to maintain the sustainability and financial viability of water utilities. Okay. Now you have to match the following columns. In the left hand side, it is economic efficiency versus fairness in supply. Number two is affordability versus financial sustainability, and three is development decision versus capacity restrictions. And their examples are in the second hand column. Uh, Option A is provide subsidies to go for revenue recovery of services. Option B is meeting water demand or protecting resources. Option C is trade-off between equitable distribution and preferential allocation to high return uses. So I think if you have attended such lectures, these terms are clear to you. What is fairness in supply? What is economic efficiency? What is affordability? And financial sustainability, just we solved in the last MCQ. You have an idea on that. So development decisions versus capacity restriction means, so there may be uh, certain restriction in the usage of the water from environmental point of view. So that is basically your capacity restrictions. But there might be any conflict if the industry needs much more water and industrial development and early stage industrial development is required for the economic development of a nation. So it is the development decisions is wanting more water, or capacity restrictions is restricting your usage of water. So there may be conflict. So these are the conflict scenarios. These are the examples. You have to match these two columns. So Ojim has given answer already. I think it is correct only. So one with C, two with A, and three with B. Yeah, you have given it correctly. So the thing is that trade-off between equitable distribution and preferential allocation to high return uses. So it is your economic efficiency versus example of economic efficiency versus fairness in supply. So the development decisions versus capacity restrictions, it is, as I told, that it is basically your demand decisions. It is basically how to meet the water demand. It is demanding more water, but protecting the resources from environmental point of view, it is uh, it comes under the falls under the capacity restriction. So basically, it is three goes with B, and the left one is this one. So provide subsidies or go for revenue recovery of services. These are example of this affordability versus financial sustainability conflict. Okay, so we'll move on to our next MCQ. For stored water, price of water held in storage must be considered option A 0, option B constant, option C decreasing at the discount rate, and option D is rising the rate of interest. So you can give your answer in chat box. So I'll go with the answer. Not spend much time. Yeah. So if the water is stored, the price of water held in storage must rise at the rate of interest. And the effect of discounting is to cause a cycle in price of water. So option D, that is rising the rate of interest, is the correct option. Now the next MCQ is one of the key issues related to urban water pricing in India is overpricing, making water services unaffordable. Option B is private utilities aiming to generate large profit from water services. Option C is large scale subsidization of water. And option D is poor getting advantage of subsidies. So here urban water pricing is the key word here. It is telling option C, water. The explanation is as follows. Due to large scale subsidization of water, water wastage is more and revenue collection is improper in urban area. Because you can see in urban area sometimes uh, if you are traveling by bus or something, there are certain municipal water supplies. In local languages, those are called time taps. So at certain time, for example, 6 to or 8 p.m. or maybe in the morning, 7 a.m. to 10 a.m. the water is being supplied by the municipality. But at the user's point, there is no valve, so the water is continuously flowing through that pipe. So as the water is provided at a subsidized rate, that means almost at a nil charge, almost as a zero charge the water is provided. So that's why people are simply wasting the water, even in households also, not only on the roadsides. Sometimes the water those comes at certain times in urban areas, because in rural areas the waters basically are either pumped out from the underground, or in the or it is harvested from nearby ponds or something. So there is electricity cost associated with it, or it may be your hand pumps may be there for pumping that water. So people will basically reluctant, either because of the energy cost, or because of your more uh, physical work that is involved in collecting that water. So that's why in rural area it is not the scenario. But in urban area, though, because most of the urban areas are situated beside river, and municipality basically purifies that river water and supplies to the people for free for certain time. So there is basically more wastage and revenue. So the revenue collection by the water supplying body is improper. Thus, no or less improvement has been made in water supply infrastructures and treatments. So the main issue that is related to urban water pricing in India, that is large scale subsidization of water. Uh, okay, option C is correct. So okay, so B, option B is correct for urban area, but not in India. That is the case. So in general, if you consider option B, it is basically true that private entity will supply water in urban area as compared to rural area. But in India, it is still not the case. So in India, because if in India it was not mentioned, then if these keywords had not been mentioned, then the B option, you then both B and C might be correct, I think. So in India, then still we we can see that drinking water is obviously sold as commodities in some places, but still not, it is not the case for water that is being supplied for general household purposes or household uses. And drinking water, definitely not many people actually waste uh, actually don't they actually waste for general purposes, just like washing hands or something. But yes, in some cases you may see that in railway stations, sometimes people, railway stations or many, in some public spaces, people, you will see that for hand washing or for general purposes people are wasting drinking water. But that water also still in India is not supplied by uh, some uh, private entities. Those are basically government entities are only supplying that water. Sometimes qualities of water are still not maintained, but that is a separate issue. Okay, so option C is correct in this case. Okay, now you have to identify, there are two statements. So which one is wrong, which one is correct, or both are correct, or both are wrong. You have to identify. The statement one is, the water utilities in India typically run as per monolith model and have no independent regulators. Monolith means basically your uh, monopoly kind of thing, where a central body basically, or a central government, the I mean the water pricing and the water treatment related activities, and water supply and distribution related planning and other activities, those are everything, the scheduling and all those are basically done by your monolithically, that is your central bodies, that I mean that is pretty much uniform all over the country. But it does not, though the resources may vary from place to place, though the availability of water may vary from place to place, but the utilities, those are associated with the supply and treatment of water, those are basically monolith model in India. So this is your statement one. And statement two is, most of the water utilities in India are owned, operated, and regulated by private companies. So I think there, I mean, you can, I mean, there is no scope of waiting. It is pretty much obviously clear from our previous problem that we had in this case. Water utilities in India are owned, operated, and regulated both by private and public sector. So, by the private company at large, though in some cases for drinking water treatment, private companies may come into the picture. But in all the other cases, in all the other utilities, mostly public sector are owning the your uh, your water pricing and water everything water related utilities. They are basically regulating the norms and everything. So only the private company in India, it is still not the case, but it may come in the future as more and more water becomes scarce. So the scenario may come into the picture, but still it is not the case because India is still in the water stressed zone. India has not become a water scarce country, so that's why it is not still in the not completely in the private hands. Only the drinking sector is. So option or statement one is correct and two is false. Okay. So water next MCQ is water pricing can be done by charging marginal costs. Which of the following statement is true about marginal cost? So actually after this MCQ, we will take a break and then we will solve a problem based on the marginal cost and average cost. This type of concepts we will solve a problem after the MCQ. Okay. So option A is it is calculated as per economic reasons of promoting an efficient use of the resource. Option B is it is always greater than the average cost. That is, your marginal cost is always greater than the average cost. MCAC in short form it is called. Option C is it is that is the marginal cost is equal to the total cost per unit of water produced. And option D is it can be both positive and negative depending on the usage and capacity constraints. Uh, yes, previous problem you have answered it correct. Now in this case, uh, some concept about marginal cost is asked. Depending on the concept, we'll solve a problem after the break. So you can answer this in the chat box. So one is MC is greater than AC. Another one is MC equals to TC divided by amount of water that is produced. Uh, another two are as follows. Uh, how MC is calculated and option D is provided. Option A, B, D, it is MCQ, not MSQ. I think only one. I also forgot. Okay, we'll see that. So basically, the explanation is as follows. Marginal costs are based on economic reason of promoting and efficient use of resource and are strictly positive and tend to be increasing in the short run due to scarcity and capacity constraints. Average cost is based on financial reasons of cost recovery and is calculated as total cost divided by the unit of water produced. I mean, option B will not be there, I think, and option C is also ruling out. So it is either option A or D. So as it is told as it is your strictly positive quantity, the marginal cost. So that's why it cannot be negative. So that's why both positive and negative is option D also gets ruled out. Option A is the correct answer. It is calculated per economic reasoning of promoting an efficient use of the resource. Now I'll solve a problem after taking a break based on the concept of marginal cost and average cost. The average cost concept is pretty much clear that it is as we saw that average cost is basically your total cost divided by the amount of water produced. So and the marginal cost is uh, actually it is the minimum cost, which is based on the economic reason of promoting an efficient use of the resource. So we'll solve a problem on that. After we will take a 10 minutes break or 5 minutes maybe. How much do you want? 15, it is 7:15. So we can join at around 7:17 maybe. 7 minutes break we'll take. We'll join at sharp 7:17. And we'll solve a problem on MC and AC. Okay, we'll join at sharp 7:17. So we're back because I didn't take much break because today some certain some more slides are there to cover. That's why only 2 minutes break is 2 to 5, or we'll wait for 1 minute. Only Jobin and Ojim I can see have joined. I don't know how many people left in the beginning. In the beginning, there are 2, 3 more people are there. Where are they gone? Charan was there. Where is he joining maybe? Or you can go ahead. He may join in the meantime. We'll wait for 1 minute and we'll start. 1 or 2 minutes maybe, or you can ask any question if you are having. Or if you have watched the recordings and you have any doubt or any problem on that, or if you have found any mistake I have done, then you can also mention. Sorry, so we can start. So the problem is basically on the AC and MC, that is average cost and marginal cost concept. So the problem is as follows: water utility supplied is 20 mld, that is megaliters per day or million liters per day. It is 20 to 10 to the power 6 liters per day of water that costs rupees 5 lakhs per day. Now, utility further required to add 10 mld capacity, that is 10 million liters per day capacity, for which additional cost of services was estimated at the rate of rupees 1.3 lakhs per day. LPD means lakhs per day. This is in rupees and this is in liters. Now, the current uniform tariff is set at rupees 15 per kiloliter. This is uniform tariff. Based on the given data, answer the following questions. So, option A is you have to calculate the MC, that is marginal cost of water services in rupees per kiloliter. you have to calculate the average cost of water services after 10 mld capacity expansion, that it is told in the question that additional cost of services was estimated to be rupees 1.3 lakhs per day, and by what percentage uniform tariff must also be increased, that is currently set at rupees 15 per kiloliter, to recover the total cost of services after the capacity expansion following average pricing. So these three questions you have to answer. You can try. I'll wait for 5 minutes around. You can take time up to 7:30 to answer this. I'll wait for 3 minutes. You noted down all the relevant information. So basically, average cost equals to uh, total cost divided by the amount of total amount of water. So that is basically that concept will come into the picture. So the detail, I mean, you have answered. I've not seen the chat box. Okay. Mm, okay, I can go with the solution, I think. But can wait for 1 minute, wait for 1 minute. Average cost is 0.0038 per kiloliter. Do you mean? I think the unit is not correct. Okay, we'll see. It is not that much less, I think. It's just a formula based problem. There is no conceptual understanding or something. This is just if you have remember the formula of average cost, marginal cost, which I don't remember also. While calculating that, we will see if you have put the values correctly, then you calculate it correctly. Yes, only the what is the average cost called, what is the marginal cost called. Those things are important to remember the formula. But if you remember it anyway, then it is not required. Okay, so we'll go ahead with the detailed solution. So the cost for uh, that is 20 mld, that is basically your 20,000 kiloliters per day of water services, is given in the question as rupees 5 lakhs per day. Now the capacity that has been added, which is expressed as delta q, it is 10 mld, that means 10,000 kld, kiloliters per day. From mega to liters it is 10 to the power 6, from mega to kilo it is 10 to the power 3. So it is multiplied with that factor. Kilo means 10 to the power 3 and mega or million means 10 to the power 6. Milli means 10 to the power minus 3. Micro means 10 to the power minus 6. So these are certain terminologies which we studied in school level. So angstrom means 10 to the minus 10. Nano means 10 to the minus 9. Ultra means most probably 10 to the power 7 or 8, I think. 10 to the minus. Uh, so those are the things. So additional cost for capacity addition, that is delta of total cost, change in the total cost is rupees 1.3 lakhs per day. It is also, I believe, given in the question. Now from here the calculation starts. So marginal cost of water services is delta, the change in the total cost divided by the change in the capacity, that is 1.3 lakhs of rupees divided by 10,000 kiloliters. I think I mean most probably you have converted into the liters, so that's why the value has come. I mean your answer was less, I think, Ajin. But anyways, you have to give it in the kiloliters, so that's why it is only 1,000, not 6. So it is basically your rupees 13 per kiloliter. So I believe my calculation is correct. So there may be also some problem. Then you may. Okay. So now post 10 mld capacity expansion, the total water supplied is the previous one, that is 20 kiloliters per day plus 10 kiloliters per sorry mld. So there is 30 mld, that means 30,000 kl. Now the total cost of services is that is it was just TC. The total cost is 5 plus 1.3. It was the previous one and it was the added. So it became to be rupees 6.3 lakhs per day. Now the average cost of water services post after the 10 mld capacity expansion. So this was actually your marginal. This is your marginal cost. So the change in total cost divided by change in capacity. It is the formula of the marginal cost. So the first answer is, I think, 13 KL. Have you anyone of you got calculated? Okay. So it cannot be that. Now after the 10 mld capacity expansion, the total cost will be total cost divided by total capacity, I think. Yes. So total capacity after expansion became 30,000. So it is 30,000 and the rupees, it was your 6.3 lakhs. This one divided by this one. So it is rupees 21 per kiloliter. So is it mentioned in the question after 10 KLD capacity expansion? Yes, yes. Sorry, after 10 MLD capacity expansion, you have to calculate the average cost in rupees per kiloliter. So that's why keep the units in mind. So it will be like that. 21 kiloliter. Now the third question, if the average cost is rupees 21 per kiloliter, uniform tariff to be set is rupees 15 per kiloliter. Hence the percentage increase is 100 into 21 that we calculated. Average cost is basically your tariff, nothing else. And in the question it is given as 15. So 100 into 21 minus 15 divided by with respect to the whatever previously the tariff was. So which comes out to be 40%. So the answer is 13. If you have calculated range between 11 and 15, then it is correct. So after the capacity expansion, the average cost will be 21. If your answer is in between 19 and 23, then it is correct. And then the percentage increase in the uniform tariff, which was 15 previously and became 21 later, then the percentage increase was 40%. If your answer is in between this range, 38.42, then it is correct. Why the range is given in each and every questions, that if somebody, some people may assume certain, I mean, people may, what they may do, they may, I mean, they may round up the figures after the point value. So that's why their answer may change from the exact value. So if it falls under certain range, then actually in your the answers those will be provided for your assignments. There also you can find that there are acceptable ranges are given. So actually it is depending on the round figure whatever they are assuming. And also sometimes as I earlier told that sometimes water billing is done not on the exact value. So if it is between 20 point something, then it will fall under 21 category or 20 category. It completely depends on the water supplying agency or body. There is no certain fixed rules and regulation on that. So based on the judgment of the people, or based on certain survey values, these kind of things are actually blocks are decided. So that's why your chance are final calculation, if you are directly simply calculating based on the formula, then it will be like this way. Otherwise it will fall under certain range, but within that range, beyond that range, it is not acceptable at all. Okay, so I think it is clear the problem. Any doubt on that, you can ask the solution methodology. This thing is basically formula, nothing else. So marginal cost is change in the total cost divided by change in the capacity. The average cost is total cost divided by, there is no delta, the total cost divided by the total capacity. And this is simply the percentage change in the uniform rate. So if you keep the units correctly, kiloliter, MLD, if you have keep a good focus on that, then the answer should come like this way. Okay. Now we'll solve the next MCQ. So for the economic analysis, a total water cost function may be approximated by option A, an inverse linear function of discharge, option B, a quadratic function of discharge, option C, a logarithmic function of discharge, option D, an exponential function of discharge. So this is also an, I mean, remembering kind of thing. So there is a total water cost function. So the equation, what you can find in that equation. So is there a, there are in all the equations there will be the discharge term, that means which is expressed with the Q. So what will be the power of the Q? So if it is 1, it will be a linear function. If it is 2, then it will be a quadratic function in that equation. And the TC is a function of Q basically. So if you can see log Q in that equation, then it will be a logarithmic function. And if you see e to the power Q, then it will be an exponential function. The total cost will be exponential function of research. In that equation, whatever the terminologies are there, you just have to remember things. You can type your answer in the chat box. So nothing else if you don't remember the equation. So for economic analysis, the total water cost function can be approximated by a quadratic function of the form a q into q square plus bq plus c, where this a, b, c, these are all constants. So the function you can see in mathematical terms, it is varying. I mean, the power 2 is present inside the equation. So if the a value a is almost negligible, if then the function can be linearized. But as the a term is there, so that's why the all the A, B, C, these are parameters of the relationship. This is estimated based on the regression analysis. There are R square value and those kind of things are there, statistical analysis, but all those things are pretty complicated. Those you don't have to remember. Just this equation is the form, and how the total cost of the water is depending on the quantity of the water, that is Q, basically discharge meter cube per hour or liters per day or whatever. So volumetric flow rate, Q is basically, so it is depending on the to the power to this term is there, so that's why it will be a quadratic function of discharge. Now next problem, it is again I think dependent on the uh, no, it is, sorry, it is not a marginal cost or uh, average cost problem. So it is basically your elasticity problem. So this elasticity, this terminology comes from the economic theory, which will the concept of which will be required to solve the problem. We'll discuss it a bit. The formula of the ETC. So the problem is as follows: the city has a population. There is a city is has a population of 50,000, and the cost of water services of that city changed from rupees 1 lakh per day to rupees 1.5 lakhs per day, when the quantity of water supplied was increasing from 20 mld to 28 mld. Now we have to calculate this one, the elasticity function, elasticity of total cost. Option A is 1.05, option B is 1.15, option C is 1.25, and option D is 1.35. So again, actually, ETC it has a formula. So I'll just tell you. Uh, so it is basically a cost output elasticity function. So it is used to measure the economies of scale. It is the percentage change in the cost of the production resulting from a 1% increase in the output. So there is a change in the cost and there is in the initial cost. So delta C by C. If you have studied mechanics, if you had physics in the plus two level, then you'd see this kind of elasticity function in the stress strain relationships, in the modulus of elasticity. These things you will see. So there is how the uh, stress by strain or strain by stress, I don't remember. So these kind of things are there. So how you are changing something, you are giving some force, so the output function is getting changing. So actually these are called elasticity modulus mechanics, and in economical theory also these is called the economics of elasticity. So this is the change in the flow rate, volumetric flow rate, and this was the initial flow rate. So change by initial divided by change by initial. If you just rearrange this, then it comes something like this. So the delta change divided by the delta Q, that is change in your cost, whole divided by total cost divided by your total quantity. So the ratio of the change is called the marginal cost or MC. The ratio of the total thing, that is called the average cost. So the elasticity is basically nothing but the ratio of your marginal cost and the average cost. Now let's come to the problem. So this was the problem. Anybody able to solve it? It is simple as per the formula. Elasticity change ratio uh, divided by the uh, your total average cost. Marginal cost is basically your change ratio, as we solved in the earlier problem, and average cost concept also you know. So I'll go with the solution. So, is there any is there calculator is allowed in your exam, in your final exam? Any instruction? Have anyone of you registered for your for the final exam? The date is almost at the end, I think, right? Have anyone of you installed registered? Okay, the problem you are calculating as 1.07. I think in the final exam, if the thing is if the calculations is are very tough, then I think calculator use will be allowed. I don't think I have not given NPTEL exams, so okay, virtual calculator is allowed. Okay, okay. So I think it will not be any problem. Calculation will not be an issue. Just your if you are wrong even in calculation, there is no issue. So just concept must be clear. In the exam, you will be given calculator in anyways. So even you can also use your mobile calculator now, or you can use any hand calculator, whichever is available to you now. For any exam, there it will not be a problem. It will just be like gate or something. Okay. So the detailed solution is as follows. Initial. So I think you gave the answer is 1.07. That means it is coming nearer to the first problem, first answer. So that is 1.05. But I think it is not so. Okay, we'll see. But if you have understood the concept, then there is no. I mean, if you have understood this formula, the MC, if you know how to calculate MC, if you know how to calculate AC, then just the two ratios are basically your EC or EC suffix Q. So the initial total cost is given as 1 lakhs and change total cost is given as 1.5 lakhs. Now total quantity of water supplied is 20 mld. After increased is became it became 28. So what is the change in total cost divided by what is the change in your quantity? So it is your zero point 0.5 lakhs. It is your 8 mld and into there was in the denominator there was total cost, so it came at the bottom, that means at the denominator, and at the numerator dq by q was there initially at the denominator, so it again pointed to the numerator, so it becomes the ratio between the marginal cost and average cost, which is nothing but the measure of the extent of economies of scale, so which is your the change, that is the difference between these two divided by the initial total cost, that is 1 whole divided by your change in the quantity, that is 28 minus 20 divided by 20, that is your initial quantity Q. I think you probably considered 1.5 here and 28 here, right, Ojim? Maybe that's why you got certain answer. Uh-huh. So actually Q means Q1 here and TC means TC1 here. So whatever, because generally if we consider the percentage change, then we consider it in terms of initial cost, not the final cost. So that's why here also in our case, the for Q and TC also we are considering the Q1 and TC1, not the changed one, to calculate the MC and AC. So it became 0.5 divided by 0.4, it becomes 1.25. So option C is the correct. Now next MCQ, the shadow price of water when water is scarce is option A positive, B negative, C 0 and D infinity. I think we saw that in the MCQ of the concept of marginal cost and average cost, we saw it to be positive, because when water demand gets increased and water supply also increases accordingly, I mean, if the demand gets increased, then the price basically gets increased. So I think it will be positive also in this case. So even if the water is not sold, yes, not sold directly in the market, it has a shadow or implicit price as it is the measure of marginal benefit. So we saw the marginal costs concept earlier. So here the shadow price of water is the measure of marginal benefit or having one additional unit of a scarce resource. Hence it is always positive. Sorry, I didn't wait for the answer. Because we are running short of time. 10 minutes are there. Okay. So it is option A is the correct answer in this case. Now the next MCQ is the basic objective of cross subsidy model, where some users pay more than cost while poor pay less, is recovery of the costs of providing the service. Option B is provide water services at affordable cost to all customers. Option C is both A and B, and option D is neither A nor B. The basic objective of cross subsidy model, where some users pay more than cost while poor pay less, or you may call it as a increased block structure per capita basis. So which one of the following is the objective of the cross subsidy model? So if you too much focus on the objective part, then you may give it a wrong answer. But you will see that whichever is the correct answer, uh, or if no none of this thing is the correct answer, then that will be the objective basically. Because what is COP subsidy model, that is clearly stated. It is basically a consumption based model. Uh, I'll wait for a minute. So see both are hack. Yes, I think it will be true. So subsidies should be explicit and clearly limited to the poor to promote basic consumption and facilitate access to the service. So option C is correct. Okay. Now we'll move on to the next MCQ. Describing maximum efficiency in water allocation is difficult because achieving one kind of efficiency could require compromising on another kind of efficiency. Option B is social benefits cannot be maximized with water allocation. Option Third option is maximum efficiency could only be achieved only when water resources are in abundance. And option D is all of the above. Describing maximum efficiency in water allocation is difficult for which one of the following reasons, or all of them. I got for a minute. Can give you type your answer in the chat box. Okay, only Ojib is there, I think. Jobin also left. So I'll go with the answer. So achieving one kind of efficiency could require compromise on another kind of efficiency. X achieving, that is overachieving private efficiency may compromise with social efficiency. So option A is correct in this case. So achieving one kind of efficiency could require compromising on another kind of efficiency. That is why the water allocation is the maximum efficiency in water allocation. The description is difficult. Okay. Now in water supply pricing, extent of subsidies may be decided as option A, 100% consumers should receive partial subsidies. Option B is only poor consumers should get 100% subsidy. Option C is subsidies should not be given for water services. And option D is based on willingness to pay surveys conducted on different consumer classes. So I don't think anyone is on the audience. So I'll just quickly go through this answer just for the sake of recording. So if anybody wants to join in the middle, they can join. Otherwise, you will watch the recording. Okay. So based on the willingness to pay survey, adequate level of subsidized tariff can be attained, which should cover at least all variable costs, including the cost of metering, billing, and collection. So this will help consumers in making water affordable for them. So that's why option D is correct in this case. Okay. So there's nobody is there. So I think we can end the session here. We'll watch the recording later. What is happening? Just stop the presentation. Okay. So I'll wait for 2 minutes if somebody wants to join that time. Otherwise, we'll end the session after 2 minutes and we'll meet in the next week. So we just discussed the last problem, not problem, the MCQ. Wajim joined. I'll repeat the last couple of problems that I. What is the problem? So I'll share my entire screen. So, Jim, you listen up to this problem, right? We just solved two couple of MCQs. After that, what was there? I just went through the MCQs. So one was related to the describing maximum efficiency of water allocation. Why it is difficult? It is because of achieving one kind of efficiency could require compromising on another kind of efficiency. For example, overachieving of private efficiency may compromise with social efficiency. So option one was correct in this case. And you can watch the recording later. The last MCQ was uh, in water supply pricing, extent of subsidies may be decided based on the willingness to pay surveys conducted on different consumer classes. So if only poor consumers get the 100% subsidy, then I mean it is basically your uh, maybe lower middle class people, they may protest or something. The 100% consumer should receive partial subsidies. Then it may not be fair for poor class of people, because the upper middle class and the rich people who are uh, using the water for luxurious uses, then equal subsidy for all is not a good option. But if at all subsidies are not given for water services, then many sections of people will be deprived of the from the services of the water. So only if surveys are conducted on different consumer classes based on their willingness to pay, then only the adequate level of subsidy in deciding the water tariffs, uh, just like the cost of metering, billing, and collection. So this costing and pricing can be done based on the willingness to pay surveys. So this was our last MCQ. After that, we just concluded. Time is also over, I think. So if you have any doubt, you can ask. Donesh just joined the last moment. So okay, thank you so much. Uh, Thank you. This compliment means a lot to me. Thank you very much, Ajim. Jonesh, if you have any doubt, you can also ask. Happy Teachers Day. Same to you. If you don't have any doubt, you will join. Actually, I am just a PhD student like you. I think, Ajim, I have. You can just stop the recording. Resume the recording. So now the Sari will also take two or three more sessions, I think, live on YouTube. So you can attend those sessions if you wish. Surely go about. Yeah, yeah, definitely. Yeah. Okay, so I think you can end now. Meet you in the next session.